If you are, we have to change your resume.
No, I don't need to. I can talk. What we can maybe do is talk about the walls or something more interesting.
Okay.
At some point.
You have a lot of fun stuff up on the walls here.
Oh yeah. You know, to me this is normal, right? You do analysis, you do design work, you draw it out, you put it on the walls so that people can talk about it. Yeah. And you know, just outside the corner, just down the corridor, there's a general manager. So when he takes it upon himself to want to explain what is MSF all about, what's our CMMI process improvement method about, he actually hauls them down here and he walks them around the walls and shows them the pictures.
Now who are you? That's my favorite famous question to start off with.
I am David Anderson.
Okay. And what do you do here?
I work in the Visual Studio Team System as a program manager. I look after MSF, which is the Microsoft Solution Framework. It's a process methodology for building software. In other words, my job at Microsoft is to teach our 8 million software developers how to be more productive.
Can you just start with our employees here?
Well, we like to say that Microsoft isn't a typical representative of our customer base. Yeah. You know, there are teams at Microsoft here who have, there's such a broad range of problems. There's MSN and web properties, and they can be releasing stuff every day. Yeah. And the other end of the scale is Windows Longhorn and what's beyond that. Yeah. We're talking thousands of developers, just a huge problem. Yep. And the Visual Studio products are really aimed at IT departments, anything from 5 people to 500 people. Yeah. And the sweet spot of what we're teaching is probably in that 5-person to 100-person kind of range. There is some activity going on to take what we're doing and apply it to Microsoft, and it's quite early days with that activity, and we're focusing on developer division first, and I have been sucked in to help on that. So come back and talk to me in a year or two and
you'll get around the Longhorn.
See how it's going.
But some of the people I've been listening to are like Jason Fried, who runs a small ISV with 2 guys on it. Now it's 5, I think. Mm-hmm. And they've done an amazing amount of software that's really cool, and customers are just raving about it. And his theory is remove some of the process and and get the team size really small, so that you can ship fast and you can coordinate fast. But that doesn't really work here, and it probably doesn't work at a lot of projects, does it?
I think if you can reduce the team size down to something small, that makes a big difference. If you can put 4 guys in one room and they can talk to each other all the time, really high fidelity, that makes a big difference. But there's a certain scale of things that it doesn't work. And there's a management problem, which is you get what you're given. You're appointed as a manager and they say, here are your 30 software developers. You didn't get to choose them. And lots of guys in IT departments all over the world face that. People in product development, they face that. Yep. And there's a range of scale here in Redmond. We're kind of spoiled. We get a lot of resumes at Microsoft, and we get to pick and choose some of the brightest, best people in the world, and they come here because they want to work for the company. Yeah. They come here for that egalitarian motivation of they can do some really great products, and they've got this huge audience that they can take those products to. So we aren't really like a lot of our customers. And some of my previous jobs, I've worked in Sprint's IT department, for example. Actually, it was the sprintpcs.com. It wasn't really part of IT. And it's in the Midwest, and it's an IT department. They hire college grads, and they're just average software developers. Some good, some not so good. And they're not all Microsoft hires. And so many managers have that problem. but they still have to deliver good quality software on time and on budget, ideally. And they need help, and that's what I'm here to do. The company hired me because I have that experience. My mobile phone rang one day. I was sitting in a bar in downtown Seattle, and picked up the phone, and a few buddies with me, and I read out the number, and they said, "That's Microsoft." I'm not sure who I know at Microsoft. I answered the phone, and the guy who actually sits in the office next door here, Sam Guckenheimer, he was on the other end. He said, "Hi, I'm Sam. I'd like to offer you a job at Microsoft."
Isn't that a cool feeling when that happens? I didn't quite get offered a job.
Well,
my boss's boss's boss called me up and said, "Have you ever considered working at that?" And then he threw me through the interview loop.
Well, I still had to interview. So I did the same loop, like a day and a half of meeting people, and it turned out that a bunch of people here had read my book. It's called Agile Management for Software Engineering, and they thought there's some really cool ideas in this, and David seems to know what he's talking about, and we have just the job for him at Microsoft, so here I am. And we're trying to put a lot of those ideas into our product, into the Visual Studio Team System product.
How would you explain your ideas in a 2-minute pitch? Give me the 2-minute pitch.
Okay, so
where's your book? You don't have a copy of your book here.
I've lent books to so many people that they disappear, and right now I don't have a copy of my own book on my bookshelf. It's published by Prentice Hall.
And how thick is it?
It's 300 pages.
Okay. So 300 pages in 2 minutes.
My work focuses on applying the teachings of two management science gurus. One is Ellie Goldratt, and the other one's W. Edward Deming. And Goldratt has something he calls the theory of constraints, which basically says if you can identify the bottleneck in your process, you should focus all your management attention, all your investment dollars in alleviating that bottleneck in whatever fashion is appropriate. And he has some guidance on how to do that. And initially that started in manufacturing, and then he had a solution for project management, and there's one for distribution channels and so on. And I took all this theory and figured out how to apply it to software engineering. And some people have said, well, that can't possibly work. And it does. And recently there's one department in one of our IT groups here at Microsoft. The audience might not realize that we have 8 different IT groups in the company, but one department in one group has implemented the theory in my book, and we're taking the results to a conference later this year. But
What conference?
It will be the Theory of Constraints World Conference in Barcelona in November, and they've increased their productivity by 150%. They've reduced their lead time from 5 months to 5 weeks. The due date performance, which is kind of a manufacturing term for did you deliver when you promised you would, has gone up to 98%, and they've gone from the worst performing department in that IT group to the best one in only 9 months.
Wait a second. How did they achieve? How did they achieve that?
Well, I have the case study kind of in my whiteboard, but I don't want to spoil it. I'm going to hold the story back till we have the full white paper in the conference.
Okay.
But we've had some good results, and basically what we did is we identified where's the bottleneck in this process, and the theory goes that you protect the bottleneck with a buffer so that you don't keep overloading it and people aren't running around like headless chickens. And then once you do that, the slack capacity in the rest of the chain opens up. And one thing that happened with this is that we discovered that the testers weren't nearly as busy as the developers, so we reassigned some headcount. We moved some of the testers into development, and that increased the productivity. That was one of 3. We made 3 management interventions, and that was one. So just an incredibly powerful technique that people said can't possibly work in software, and over the last 5 years I've shown that it can. And we've put some of that capability into the Visual Studio Team System product, the capability to actually measure and identify the bottlenecks. And we do that using a standard reporting chart, which maybe I can show you if we can set that up. But it's called, in manufacturing, it's called a cumulative flow diagram, but we're calling it a work remaining chart, and it basically just shows a work remaining chart.
Okay.
And it just shows the number of work items queuing for different things, the state that they're in. So let's say it was a change requests. Say it was a sustaining engineering organization, they get change requests. The change request comes in, it's in a proposed state. So they are queuing for triage. And then you triage them and you accept some, so now they're queuing for development. Then they get developed at Microsoft, we call that resolved. And they're queuing for testing and so on. So the chart simply allows you to see at a single glance how many things you have queuing and where they're queuing. And if the gap on the chart starts to go like this, well, the queue's getting bigger, and that's a really good indication that you've got a bottleneck. And from a management perspective, you can watch that on a daily basis and you can do stuff about it. Okay. You can watch the trend in
what kind of bottlenecks do you see in software teams? What are the most common, or what are some memorable ones that you
It's people can just be simply overloaded with too much work. So that causes a bottleneck.
I'm there. I think most Microsoft employees are.
Other things that happen, there could be some problem in the process. So, for example, you give developers some work to do and they start working on it and they figure out they don't have all the information they need. So they shelve that work and they go start something else. And over time that can accumulate. So from a management perspective, you can see problems occurring and the manager should go ask, why have we got this growing backlog of work that's all being started and not finished? Or we've got this queuing work here and it's not happening. So you might see a rising queue of things for testing, but they're not being tested. Well, it turned out that the testing department didn't have the environment, and the environment wasn't working because there was some component that the supplier hadn't supplied and no one had escalated it. And the manager can see that from the chart. So that work remaining report's very critical piece, and it's lean manufacturing theory brought into software. So the same way that Toyota is managing their supply chain, or the way they organize distribution centers, or how they organize the production line, is the same underlying theory that we're using to identify bottlenecks in software development. And it really does work. We've got case studies from my past, and now case studies at Microsoft, and hopefully case studies from our customers soon. So you asked me about the two things. The other one is Edward Deming, and he is a famous quality assurance guru.
Yep.
Who basically said that any work activity can be separated out and analysed to study its variation. Even if you're just hitting a nail with a hammer, you'll never do it perfectly every single time. Maybe you can invent a robot which hits it and it's very accurate. That's simply low variability. With a human, there's more variability in it. And any task that humans perform can be measured for its variability. And he and his predecessor, a guy called Walter Schuhart, studied this and came up with a theory that there was what Deming called common cause variation, which is the natural variation in the process. If I'm hitting a nail with a hammer, sometimes I'll hit it square on the head and sometimes I'll be slightly to the left or right. And the natural variation is coming from my wrist and my arm and so on. And then there is special cause variation, which is the idea that something external affected the process.
Yeah.
And for example, I could have gone skiing on the weekend and come back with broken arm, and now it's in a cast, and clearly my hammering ability will be affected by that. Or it could be something else out of my control, like bad weather, or howling gale blowing or something, and I can't keep my balance while I'm hammering nails. So if you can separate out the common cause variation in the process from the special cause, you can focus management attention on those special causes. And in a project management world, special causes are anything which are abnormal, like your testing environment not being there, as an example, or someone suddenly going off work because they've had a death in the family, perhaps. And, you know, that would be another kind of example. It's a special cause variation for an individual on a team. So the way we've brought that into the process is that we ask people to track issues, problems that occur, by basically meeting as a team every morning and discussing what are they working on, what are they working on next, and is there anything blocking them, or anything they can foresee in the very near future which might block, and that goes in the issue log.
Yep.
So the project manager at Microsoft, we'd call them program managers, they are responsible for keeping that issue log empty. And if they don't empty the issues fast enough, if they can't find resolution, then the issue will block something and you'll see work items blocking. And of course that slows down productivity. It's very similar to the bottleneck kind of problem. So we've put the appropriate measuring capability in the tool and in the method and the reporting to allow us to monitor for special and common cause variation. And why this is really, really important is that Deming essentially taught managers how to be good managers. And he said that the managers can only make 2 mistakes in their entire life, the 2 types of mistake. Mistake number 1 and mistake number 2. And number 1 is interfering with the work that's ongoing while it's varying within its common cause variation. It's the micromanagement problem of, well, today you developed 2 scenarios and yesterday you only did 1, so yesterday you guys were slacking. Or tomorrow we didn't get any done. So you know, clearly you need to work harder. You did 2 on Wednesday, why none on Thursday? That's micromanagement. Mm-hmm. And software developers and testers and, you know, who knows, any knowledge worker, whether they're in software or not, they hate that. They hate interfering managers. So we're trying to teach management using our tool how to stop interfering with the normal course of software development and how to objectively identify what's normal and what's not normal. So mistake number 2 is not doing something when something not normal is happening. And that's really just a lack of service. If some team is blocked or they're likely to be blocked, and you can predict that in advance from the data that you're getting, if the manager doesn't act, just sits back and lets it happen, well, productivity will fall. Yeah. And the team will also be demoralized that the manager doesn't help. So mistake number 1 and number 2 lead to very poor motivation. Psychologically, they're very damaging to the workers. And in software engineering, it's a knowledge work task. It's all happening in here. Yep. And if you're not well motivated and you don't feel good about coming to work, if you don't feel good about your boss, then you won't be productive. Yep. So we're introducing this objectivity and what Deming called his theory of profound knowledge, which is separate out common cause from special cause variation and teach managers how to manage properly. Yeah. And that's really what it's all about. I've taken Goldrat's work, some work from lean manufacturing and Deming's work, and figured out how to use it in software engineering, and now we're putting it in our product. I
bet, because I've heard rumblings around Microsoft that developers hate process, right?
They do.
Because they look at their work as a creative craft, like music, you know, creating music. And how do you put process on creating music, you know? Do you go in and tell Sting, hey, you need a process here, you know? Well, and you gotta churn out 4 more notes to, you know, in the next hour because you did, you know. And how do you win over developers who probably are like, I don't want process. I want to go and just go and close the door and come up with my brilliant software the way I do.
I think in any...
I can just imagine telling Dave Weiner, you need process.
Oh, yeah. In any creative discipline or any sport, as another example, discipline is really important. Really great musicians get great because they have a discipline about how they play music and they practice and they rehearse and so on. And I think really great and long-lived bands, to carry on this music theme, also have a process, even if they don't really know it or perhaps couldn't write it down. But a band that doesn't have a process and they go in a recording studio, they'll burn away all their money and they won't be successful. So process matters as long as it's the right things that are being focused on. And where I think software engineering went wrong for a long time is they monitored things like lines of code being produced. Well, if you're going to measure me by how many lines of code I'm going to produce, I know how to beat that metric. It's Control-C, Control-V, Control-V, Control-V. And cut and paste is a marvelous way to generate lines of code. So I don't think in an object-oriented world of technologies like C# or even C++ for that matter, the last 10 or 15 years, those kind of technologies that have been available, there isn't a direct correlation by how many lines of code I wrote today and how productive I was. So another piece of the picture is we've been teaching people how to define what is customer valued functionality and capture that in very fine-grained definition up front, early in the process, and then focus on delivering something the customer values. And we measure the production rate of things the customer values, and not the process of hitting the keyboard or whatever it might be.
That sounds like weblogging could play a part in this, right? Where you can hear customer requests coming in. Because I'm doing that. I'm out there and seeing what people, at conferences and on the weblogs.
A good friend of mine, a guy called Martin Geddes, who's known for his Telepocalypse weblog, about 3 or 4 years ago, he had this idea of what he called the transparent value chain or the transparent organization, where his opinion was that the customer ought to be able to access directly the person doing the work for what they valued and be able to give them direct feedback. And to be honest with you, here in Developer Division, and particularly on Visual Studio, we are really good at that. As a team, we have maybe 350 engineers. I'm guessing that about 100 of them have weblogs. Many are on MSDN, but not all of them. Like my site's not on MSDN.
What's your blog name?
agilemanagement.net. And so therefore you go down this corridor here, 4 or 5 of my colleagues in this corridor alone have weblogs, and they post stuff about what the team's doing, what their part of the product is doing, and customers respond back. And recently we've been getting some really great feedback from customers saying, we love what you're doing with weblogs, we love this access. I never dreamed I could get this feature in the product, but now I even know the developers are developing it. And I think that's the way of the future. If you want a really agile business, you need to be able to execute on, here are the requirements, let's turn them into working functionality really quickly with really high quality. But a key point in our message is quality is defined by the customer. Therefore, you get much higher quality if you have direct contact with the customers. Yeah. It's a vital piece of the strategy.
Okay, I got some teams for you to go over and talk to. Because some teams, like Direct Developer Division, definitely are over the top getting it.
Right.
Probably because their boss started blogging. Soma blogs.
I think the management support is fabulous.
Eric Rudder blogs. So.
Essentially, my entire upline management blogs. My boss, who was in the office just across here, I'm about to change bosses, unfortunately. Not that I don't like my new boss, but you get
attached to old
you get
bosses,
used to having a boss. So anyway, he's got a blog.
You got to train your new boss.
That's right. Got a new boss to train. Our general manager has a blog. Our VP has a blog, and up that chain. And there's been tremendous support for that.
Yeah.
And I never see any of the angst that we often see discussed internally and externally about, is blogging dangerous and can you get fired for blogging? People in the team system group here really just don't worry about that. They get on there and they blog about the product and they contact the customer and say what they want to say.
Yeah.
It's working really well.
That's the way it is.
It is.
So what's up on your wall?
So what we have on the walls here are some diagrams of the process flow for.
Let me get on that side. Yeah, there you go.
For MSF, for CMMI process improvement, and these diagrams are done using the UML eDoc profile that was developed by a guy called Keith Duddy in Australia and an IBM team 3 or 4 years ago, and it's a notation for describing, here's a bunch of inputs, we perform an activity, something happens and we get some outputs.
Yeah.
It's really good for describing hierarchical business processes. So on this wall we have the 5 tracks in.
Is there a chart in particular you want me to look at?
Well, if we look at this one, this build track talks about planning an iteration, building a product, implementing developer tasks. And so this is the high level of what's going on while you're generating the code. And then over on my other wall, we actually have the drill down. Imagine this is dynamic and you could double click one of these boxes.
Okay.
So what you get over on this wall is the drill down of that. It's the next level down. It's actually a 3-level hierarchy in total. So for anyone who's familiar with MSF or Microsoft Solution Framework, they'll know about version 3. It had 5 phases. We now call those phases tracks. And those 5 tracks drill down into something we call work streams, and then within a work stream you get an activity. So for example, plan and iteration here has activities like plan the stakeholder involvement, review the plan, and then take that to the program management office and have it reviewed and obtain commitments from everyone. Once you get the sign off on it, off you go and develop your iteration.
Yeah.
And what's on the wall here is the master copy. You'll see that there's lots of red ink on here. So people come in and they say, I've realized this thing's missing or this thing's in the wrong place, so we'll take the red pen out and we'll update the charts on the wall. It's very agile from a modeling perspective because there is that old thing of you have your drawings in some tool and you have your working code somewhere else and they get out of sync over time. And that's led people to be skeptical about the use of modeling tools. So we're actually, in the second half of this year, taking these diagrams and putting them into a domain-specific language using the Corona product, which is codenamed Corona. It's the domain-specific language modeling tool piece of the Team Architect product.
Okay.
It essentially allows anyone to create their own modeling language. So we're going to take this UML eDoc profile, put it in Corona, modify it slightly to be specific for MSF, put all these diagrams into it, and then we can export the content of the diagram as XML. We can transform it into the format that's displayed in the website for the MSF guidance, and we can round trip it back. So someone who wants to customize our process template, and with a CMMI process template you would typically do that for every project. In CMMI is the Capability Maturity Model Integration from the Software Engineering Institute at Carnegie Mellon University.
Got it.
It started out life as a method for assessing the capabilities of US defense contractors.
Okay.
We're about 15 years old. and it's gone through various iterations, and the latest one is CMMI version 1.1. And the CMMI has become popular particularly with IT departments who don't want to get outsourced, and with Indian and Chinese outsourced vendors who use it almost as a guarantee. It's give us your business and we'll give you back precisely what you asked for because we're a really high quality organisation, and here's our assessment or appraisal from the SEI to prove it. So that's why we're developing the method, and typically in a mature organisation following the CMMI, they would customise the process for every project in their portfolio. It would be slightly different for every project. So we'll have the ability to do that customisation using the Team Architect product, and then forward generate the process guidance outline. And then you could go into a XML editor like InfoPath and actually edit the English language stuff and then round trip it back into the designs, so that the design and the guidance, the HTML pages, are never out of sync.
Right.
Which is really cool. It's a really cool use of domain-specific languages in the Team Architect product, and it's a fantastic way to actually have quality assurance in your quality assurance group.
Okay.
If you can follow that.
Yep.
So that's what's on the walls basically, and I'm really encouraging this. You know, you see some articles on my website as well where I've taken digital photos of models on the wall. It's such a tremendously powerful way for development teams to communicate. And often they do stuff on bits of paper, or they enter it into tools and it exists inside some box somewhere. And one developer knows how it all works and the rest of them never really go look at it, or if they do, they're scrolling the screen around and stuff. You know, paper's cheap, printer, everyone's got a printer. Print stuff out, put it on the wall. It's so much fun.
Yep. Anything else you want to show us on the charts?
I think that's good.
I can. I mean, I'm glad I have video because you can really get a sense of how it does improve your productivity of understanding a problem space,
Right.
and then how you can work with other people and have them come in here and discuss something.
Sure.
Anything else we should know about what you do and how you're?
I think the key thing is that we're launching the beta of our CMMI process improvement method on MSDN this weekend, July 4th.
Oh, really?
And
you don't want a vacation?
Well, I'm actually going on paternity leave for a month.
Well,
so,
congratulations.
I get to shut down for a while and come back in August and see all the feedback.
Yeah.
We've already had the other flavour of MSF version 4 called Agile Software Development. That's been out there for a while.
Okay.
It's also in beta. And both of those will be polished up and they will ship with the Team System product later this year.
Very cool. Any other tips or tricks for developers? How do you know when you're going wrong? Well, obviously you're slipping dates and you're probably demoralized and you know.
Wow.
How do you know when you need to read your book?
I ask people to focus on the velocity in the process, to measure. It doesn't matter what it is. People have said to me, well, you've got all this experience in something called feature-driven development, which is very analytical, and these little tiny things called features are very well defined. So that's great. You can measure 5 features a day, 3 features the next day, whatever, 10 features the following day. And it feels tight and mathematical and statistical. And I've said, well, it doesn't matter, define the work items that you're working on and just start measuring how many you do today or tomorrow, and not at the individual level, at the team level. And people have said, well, that can't possibly work, and I've said, okay, how big do you think a change request is? And they'll say, gee, I don't know. How long does a task take, and what kind of a task? Oh, any kind of a task. How long does it take? And they say, well, I don't know. It could be any length. And I said, well, in the IT department I've been working with, a change request takes from half a day to 21 days. But the average one takes 7 days. And we've got 9 months worth of data to prove the average one takes 7 days.
7 man days, that is. So we measure on a weekly basis how many change requests they're producing, and we focus them on that velocity. We don't ask them to go and estimate every single change request and then like hold their feet to the fire on it, because if you're going to punish someone for being late, you'll get overly long estimates.
Yeah.
And you can be sure that the work will fill whatever the original estimate was.
Yeah.
Productivity goes up when you focus people on their production rate and don't focus them on this conformance to plan concept. And if that's one thing that you could change to make a big difference, it's stop estimating and start measuring velocity.
Interesting. I like everything. I'm trying to filter what you're saying and put it on my own experience, which is posting video.
Right.
But I'm trying to get back into software mode. What do you do? When the Longhorn team called you up or calls you up, what's your first couple of days? How do you look at a team and start a plan? What's the first thing you do?
When someone calls me up and says...
And Longhorn team is not a good one, but any...
Well, there's so many teams in Longhorn.
Yeah.
I am actually working with one small team in Building 40 that's part of Longhorn, and they've just recently started doing that. They focus on the velocity and keeping that chart. And that's an ongoing experiment. I'll talk about that one perhaps later when we have some results. But when someone calls me up, usually the first thing they do is say... maybe it's a manager and they'll call and they'll say, I saw you presenting at this conference, or I've read your book, or I saw your website. Can you come talk to my department? So usually I go do that, and then I do a brown bag or something. And they'll come back and they'll say, well, that was really great and people really liked it, but how can we implement it? So then I go back, and typically I have them do something like this. I say, okay, how does your department work? And they say, well, we've got 4 customers and they send us change requests, and they come into a big pile here, and then we send them to the developers, and we send the code once it's developed to the tester, and it goes for testing. And they start to tell me the story of how the department works.
Yeah.
And I identify what they should be measuring, and sometimes they're ahead of the game and they're already doing it and they have the data. So then I would ask them to start measuring it, and that's really the first stage. What should you measure, and start measuring it. And once we have some data, then we can start to make some changes, if that's appropriate. And generally, if they've called me up, then they want to do, they want to make some kind of improvement. So with this one, we put in a little buffer that said, we've only got 3 developers here, and they'll be doing a task each. So we'll have a buffer that says there'll only be 8, there'll be 3 for the developers and 5 more waiting in the queue. And it doesn't matter if you've got 100 things backed up here, there's only 8 things that we've committed to. And once a week we'll hold a meeting with the customers, and if there's a couple of these slots are open, then the discussion is, okay, you guys, you've got 100 things on your backlog. Between the 4 of you, figure out which 2 win the prize this week. And they go into this buffer. So what happened when we made that change is that these developers suddenly found that the world was totally under control, incredibly predictable, and they weren't being randomized, which is a term that we like around the Microsoft campus when somebody appears in your office and asks you to do something you weren't planning on.
I am the randomizer.
Robert the randomizer. So, so that's typically what I do. Once we have some data and we can understand how things are moving in terms of the work requested and how it moves through these functional groupings, then we start to make some changes. It's about objectivity. There's far too much subjectivity in software engineering, and that, in my observation, leads to people being demoralized and getting unhappy about being at work.
Yeah. How did you get into this field?
Oh,
You don't just wake up as a 13-year-old and say, I think I'll study software development productivity and how to improve it.
You know, there is no master plan. So I spent the early 90s working in 2 startups. One for 5 years. We went through the seed funding, the A round, the B round. I fell out with the B round investors and I quit as basically the CTO, employee number 3 at that particular company. And I quit having really made no money, and the internet bubble thing hadn't happened by that time, so I was kind of hard up. I had some debts to pay off, my credit card, that kind of thing, and I got a call and someone said, you want to come work at IBM as a contractor, and it was pretty good money. It was like 1,000 sterling a week or something, and I paid off all my debts. And my plan was to save up money doing that for 2 or 3 years and start a mountain bike touring business in Scotland. I was going to have a website, which was a really new, radical idea in 1996 or thereabouts. And I was going to advertise for American tourists to come to Scotland. I was going to take them on bike tours of the mountains, basically. And while I was doing this job at IBM, trying to make some money, I got an email one day from a guy I knew in America, part of IBM. It said, do you fancy doing a gig in Hong Kong? And what that turned out to be was a project in Singapore. It shows how far removed he was from the source. And that particular project is now famous. There are now 4 books in total that have been written about what happened on that project. And what came out of it was the feature-driven development Agile method, a new analysis and modeling method that uses a sort of domain-specific version of UML. And this bank, relatively medium-sized bank by world standards, it's now the 1st or 2nd largest one in Singapore or Southeast Asia. But a global 1,000 company, but down towards the 4-digit end of the 1,000 there. And they got a $20 million IT project delivered on time and on budget, which basically did banking. It does everything from $500 overdrafts to $500 million to buy a couple of Boeing 747s for Cathay Pacific Airlines. And that bank is now the most competitive bank in Southeast Asia. So they had this mission critical system. It was 3,500 pages of requirements. It was 2 4-inch ring binders about yay thick. Yeah. It's over 600 use cases and 3,500 pages. And it was 1.5 million lines of Java. 53 people in the project, 23 of them actually programmers. And one of the leading guys at Sun, John Gage, told us, he came to visit us, and he said, this is one of the 10 largest Java programs ever made. Well, that was 1998, so it wasn't a huge claim. But it was a sizable project, and it basically rejuvenated my belief that software was something I wanted to do for a living. And that's a big credit to Jeff DeLuca, who was the project manager, and Peter Code, who was an advisor and architect on the project. Peter Code's better known as the guy who built TogetherSoft and sold it to Borland Software a couple of years ago. So I got into software again, and I left America, and not that much later I ended up at Sprint PCS, where I was in the .com business unit. And it wasn't so long earlier that .com had been, I think, 6 servers in a cupboard and 2 people, or was it 2 servers in a cupboard and 6 people? And by the time I arrived, it was 250 people in one building in Kansas City, Missouri. And I had this really wild and radical vice president running the show there called John Udebski. And he was a very inspirational sort of guy. But by the end of the first year, it was chaos. You go from 6 people to 250 people in 9 months. It was chaos. So I don't know what he'd been reading, but he came in with a copy of Ellie Goldrat's The Goal, which is a novel that Goldrat wrote about turning around a manufacturing plant. And he brought this into his manager's meeting one day, and he handed out, whatever it was, 10, 12 copies, one to everyone. And he said, guys, I want you to read this and figure out if it can solve our problems. And I was about to go on vacation, and I got on a plane, flew to Dallas, from Dallas to Tokyo, and on the flight from Dallas to Tokyo I read the book. And about 2/3 of the way through both the book and the flight, I had the aha moment that allowed me to connect the dots. That features and feature-driven development were the same as inventory in a factory process. And then I started, vigorously scribbling in the book. And by the end of the flight, my book was full of notes. And I didn't have a laptop or anything with me. I was on vacation. So I spent a week in Tokyo, and on the flight home, I bought a notebook, and I sat and I transcribed everything that I'd scribbled in the margins onto 36 PowerPoint slides that were handwritten. And I took them back and I showed my boss, and he said, "Wow, I think you've cracked this." And at that time we were in the early stages of process improvement at .com. And he said, "This is probably one step beyond where we want to go this first time round, so let's just shelve this for now and we'll come back to it," which of course we never did. But Peter Code visited Sprint, and I showed him some of the stuff I was doing, and he said, "This is really cool. If you get it in electronic form, please send it to me." So about a year later, I was on a flight to London, and I finally had time to sit down and transcribe the notebook into my laptop. I mailed it to Pete about a week later, and he wrote straight back to me and said, "You've got to do this as a book." So I did do it as a book, and about a year after that, Microsoft hired me. And in between times, I was working. I quit Sprint when my first child was born. Shortly before my first child was born, the 100 hours a week was not compatible with the arrival of forthcoming child.
Yeah.
And I joined a small company that was about to be acquired by Motorola. So I basically joined Motorola's cell phone division. And in that intervening couple of years, we just did some real kick-ass projects in terms of productivity and quality, to the point where I show the slides from the cumulative flow diagrams from those, and I talk about the quality and the productivity, and I compare it with some other projects, and people are just blown away with the numbers. And guys who work on that kind of a project, they realize that they've been waiting their whole career to work on something where it all runs really smoothly and everyone has such a great time. And one of the best projects we had, it's about 18 months ago now. Actually, it was a 1-year project, but it was divided into 7-week iterations.
Yeah.
So on one 7-week iteration, nobody worked a single hour of overtime. The working day was, they arrived in the office about 9 o'clock, and a few of them grumbled. Developers, they hate to get in before 10. And
if you can get them in by 10, you're doing good.
Oh yeah. At 9:15 we'd have the morning stand-up meeting, and we'd go around the room with the what features are you working on, who needs more work, what are the issues, and so forth. And then they would go off to work, and feature-driven development's a very collaborative, team-working kind of thing, so nobody really works on their own, they work together. And by about 3:30 in the afternoon, they'd be exhausted, and we would decant as a team from the office in downtown Seattle to the Torre Fazione on Occidental Avenue, and we'd have coffee for a while, we'd chill out. Then people would go back to the office, maybe do some email, and generally they'd all left by 5:30, which is about the time anyone in Seattle will know the last express buses leave, about 5:30. So that ran for 7 weeks solid, and we shipped the product with virtually no defects, less than 3 bugs per 100 features, which features really quite closely to function points. They're about 100 lines of Java, so we're talking 3 bugs for every 10,000 lines of code, which is a stunning metric. The stabilization phase was a couple of days. In fact, the thing went so well, and both that iteration, the previous one, the next one, they maintained a production rate of 4.9 features per developer per week, with a standard deviation of 0.14, which is just incredible, and the defect rate remained at that sort of 3 per 100 level. It went so well that management pulled half the team off to go fix the software on another project. And the first thing that happened to the half the team who were pulled off to go fix someone else's bugs is they worked a weekend after 6 months of rediscovering that they had a social life.
Yeah.
And that's really what it's all about. Good management, good organizational software engineering makes for happy, well-balanced people that have a life. And I think that's what we're all looking for ultimately.
Yeah. I wish you luck.
Well,
I mean, it's not just Microsoft, right? There's famous game companies who've run into trouble with their employees, working them to death.
Oh, I'm sure.
A friend of mine is not working here at Microsoft, but he's sleeping, this week at work, trying to get through one of these pain points.
Well, I spent my very early career sort of learning that pain. In the early 80s, I was a game developer. I worked for Ocean Software, which eventually became part of Infogrames. And Ocean Software had a joint venture called US Gold, which was a well-known publishing house in the UK. And then towards the end of the 80s, I did some work for Electronic Arts. But most of the time, I worked for Ocean. And so I did the long days. And I remember one time, I was about 17 years old, and I just finished a game, about 60,000 lines of assembly language. Games were small in those days. But it basically had no comments in the source. The procedure names were usefully named, but more or less everything else was in my head or in the head of my colleague that I worked with. And I had this epiphany that at 17 years old, I was already too old to remember the contents of a 60,000 line assembly language program. And I call that Anderson's first epiphany in software engineering, that I actually had to write stuff down. And so I learned a whole bunch of the lessons that we try and teach fresh grads. They come out of college, they join Microsoft, and we start teaching them things like, you need to write stuff down, you need to review your code, you need to unit test it, and all that kind of stuff. And I learned a whole bunch of that in the very early days, because in the 1980s, if you put a bug in a game, well, first of all, if it made it into the market, the magazine guys would give it a terrible review and you wouldn't sell any.
Yeah.
And therefore you wouldn't get a good game to do next. Go paid for actually writing software, not for turning up at work. And if it didn't make it into the market while you're developing, it would blow the box up. There was no protected memory space or anything. If you walked off the end of an array in an assembly language loop, it would just overwrite all the memory and just kill the thing. You have to reboot the whole box from scratch. And that was a painful, time-consuming process. So you paid with your own labour if you put bugs in the code. You learned the hard way to write bug-free code. And I've sort of carried those lessons with me through life. After I went to college, I studied software engineering, and electronics. And then after I graduated, I've carried those lessons with me, that it's actually worthwhile to put in the effort. And I think the Agile software community, with their test-driven development movement of write tests first and write high-quality stuff and get it right first time, they're rediscovering a lot of that, because everyone had got too comfortable. Machines are too powerful. IDEs are too powerful. It's too easy to open up the debugger. As a manager, it's a smell test for me. If I walk the building at 7:30 at night and the half a dozen people still there all have the debugger open and they've been debugging for the last 8 hours, that's a fairly good indication to me that there's a problem.
Thanks for spending some time with us.
Well, it's my pleasure.
That's great. Inspiring. So keep doing it, and I
hope I'll have some exciting news to share with you in the future when we have some real case studies of what we're doing.
Okay. I'll come back anytime you want. So.
Well,
Thank you, and good luck at getting us to ship faster, because that's a mantra of us who deal with customers. So.
Sure.
Yeah.
Yeah.
Thanks.